So past paper pop quiz. This was a pop quiz too related to the past paper questions. I will solve the complete quiz. So the first question, fluorine, chlorine, bromine are in group 7, which we also call halogens. State the name given to a group 7 element. So what we call group 7 elements, we call them as halogen. The term halogen means salt formers. They have a tendency to form the salt. That's why we call them as halogens. Then explain why group 7 have a similar chemical properties. So whenever you see such question in which they mention about the chemical properties, similarities in the chemical properties depends on the number of electron in the last shell. So we will say because they have the same number of electron in the last shell. So as they have the same number of electrons in the last shell, that's why they have the same chemical properties. So chemical property is always a function of number of electron. Same number of electron means similar chemical properties. Complete a table 2.1 to show the color and the state at room temperature and pressure for some of the group 7 elements. So fluorine is pale yellow, and what is the state? It is gas at room temperature. Chlorine is also a gas. What is the appearance of the chlorine? Chlorine is yellowish green gas. And what about the appearance of a bromine? Bromine is red brown. So we write red brown for bromine and we write yellowish green for. Don't only say yellow, don't only say brown. It will be specific red brown and yellowish green. Then we have a bromine has a two naturally occurring isotope. Bromine 79 and 81. These are the two isotopes of the bromine. State the term given to a number 79 and 81 in these isotopes. So what we call the 79 and 81, we call that as nucleon number. The nucleon number is refers to the 79 and 81. Like this is a nucleon number for both of these isotopes. When we have pop quiz, this is past paper pop quiz too. Complete the table to show the number of proton, neutron, and electrons in an atom for bromine 79 and bromine 81. So first thing, how to work out a proton. Proton number is the identity of the element. The proton number is the identity of the element. So if you want to see the proton number, you can check the periodic table. I can say it is 35, but in exam, you don't have to memorize this. What you have to do, you have to just use a periodic table. Period. I'm recording the session. So when we check a bromine here, what is the proton number of a bromine? Bromine is 35. So the proton number will be same for both of these isotopes. So when we write the proton number, so this will be 35 for bromine 79 and it will be 35 for bromine 81. How to work out the neutron? You have to take a difference. So 79 minus 35, what will be the answer? 44. And 81 minus 35, 46. Number of electron, because it's a neutral. When it's a neutral, the number of proton and electron should be same. So this will be 35. But how many electrons will be there for this one? It is a negatively charged. So additional electron is there. So it will be 36. This is the pop quiz. Past paper pop quiz 2. Figure 2.3 shows a relative abundance of the two naturally occurring isotopes. Calculate the relative atomic mass of bromine in 1 decimal place. How to work out the average mass of the two isotopes, 2 or 3 isotope, any number if it is given. It's a percentage of the isotope multiplied by its mass number or a nucleon number. Then the sum, the percentage of isotope by its nucleon number. So this will be 55 multiplied by 79 plus 45 multiplied by 81 divided by, because the percentage is given, so we'll divide by 100. What's the answer here? Relative atomic mass 55 into 79 plus 45 into 81. 79.9. So we just write 79.9. The unit relative atomic mass, you write the unit as gram per mole, okay? G/mol, gram per mole. But the unit here is not having mark here. The working is having the mark, like how you get the answer and what is the value. Chlorine displaces bromine from aqueous potassium bromide, but does not displace fluorine from aqueous potassium fluoride. So if we have potassium fluoride and we react chlorine, we observe there is no reaction happen. But if we have a chlorine and we react it with potassium bromide, so we observe that the displacement occur and it form potassium chloride plus bromine. Write a symbolic equation for a reaction between a chlorine and aqueous potassium bromide. So we want an equation here. So chlorine is reacting with aqueous potassium bromide. So potassium bromide or sodium bromide. It's a case there. In this case, we have to write an equation between chlorine and aqueous potassium bromide. So chlorine is there, Cl2, reacted with potassium bromide, that is KBr, because chlorine is more reactive than bromine. So chlorine is more reactive than bromine, so chlorine will displace the bromine from its compound, so it will form KCl plus Br2. And we just balance the equation because the state symbols are not required, so we are not supposed to write. This is a balance equation. So first, whenever you write any equation, first try to write the correct formulas and then try to balance the equation. This was a pop quiz.
I did the focus. First time this year.
First time the year. Yeah, first time in the year.
Yeah,
2025. State why chlorine does not displace fluorine from aqueous sodium fluoride. So why it cannot displace? Because chlorine is less reactive. Because the more reactive element displaces a less reactive element from its compound. Because the chlorine is less reactive, that's why it's not able to displace fluorine from its compound. Silver nitrate is a colorless solution which contains a silver ion. Describe what is seen when aqueous silver nitrate is added to sodium chloride. When aqueous silver nitrate is added to sodium chloride, what will the product form? The silver will combine with a chloride ion, so it will form silver chloride. And what is the appearance of a silver chloride? You have to learn the appearance of silver chloride. It is white solid or white precipitate. Okay. Why we call precipitate? Precipitate is a term used when two solutions are mixed together and it will form a solid. We always call that as PPT or precipitate. So if it was silver bromide, what will be the color? No, if it was silver bromide, it will be yellow precipitate. Cream precipitate. And if it is silver iodide, it will be yellow precipitate. You have to memorize the color of the three precipitate of silver. If it is silver chloride, it is white. If it is silver bromide, cream. And silver iodide, it will be yellow precipitate. So you have to memorize these colors. If this was the same question, but it is written like sodium bromide was there, then what will be the answer here? So what will the answer? When silver combined with the bromide ion, it will form a cream color precipitate. Then write an ionic equation for a reaction of we need ionic equation. In ionic equation, we just write the changes in the ions which cause these precipitate. So the precipitate is because silver chloride is a precipitate, the solid. What are the ions react to form silver chloride? So there is a silver ion and there is a chloride ion. So this is an ionic equation in which ions react to form a compound. Okay. If they ask us to write the full equation, so what we'll write? Silver nitrate. So we write AgNO3. So we write AgNO3, which is aqueous, they mention here. Sodium chloride is also aqueous, so NaCl, also aqueous. Form silver will combine with chlorine, displace. So AgCl will be there, that is solid, and it will form NaNO3, which is all nitrates are aqueous, so this will be aqueous. This is a full equation. What is the ionic equation? The ionic equation, we write the ions which causes the change, which form a solid, liquid, or a gas. So what simply happened? This is a sodium here, and sodium in aqueous, it cancel out. Nitrate in aqueous is also cancel out. So what ion we are left with? We are left with silver ion and the chloride ion to form a silver chloride. So whenever you need an ionic equation, what you simply do, the compound, solid, liquid, or a gas which is formed. So here silver chloride is a solid form. And how this solid is formed? By reaction of a silver ion and the chloride ion. So how to write an ionic equation? It is important to understand that you don't have to show this cutting part, like you don't have to cut this in exam. You're not supposed to show the working. You have to write the final equation. But how you can write the ionic equation? We were having a silver nitrate, which is aqueous. We have sodium chloride, which is also aqueous, and it is forming silver chloride, that is solid, and it is forming sodium nitrate, that is aqueous. How to cancel out? We cancel out the common ion in aqueous solution. So which ion is common in aqueous solution? This is the nitrate ion aqueous and nitrate aqueous, so we cancel out each other. Then we have here silver is aqueous, here silver is solid, so we cannot cancel out. Then we have sodium ion in aqueous here and sodium ion in aqueous, so we cancel out that. So what ions are left? We are left with silver ion and we are left with a chloride ion to form AgCl. But in exam, you're not supposed to show this working. Directly, you have to write the answer. So the simple way to write the answer is for ionic equation for precipitate. First, you write the formula of the precipitate. Yes.
For any formula, if it is solid, it will not be called.
Yeah, it would not be. So simply you write a formula for the precipitate, like here AgCl is a precipitate, so which contain Ag plus ion and contain Cl minus ion. That's it. And state symbols aqueous, aqueous, and solid. Yes.
What is the mark distribution here?
1 mark is for writing the charge on the ion, 1 mark is for the state symbol, and 1 mark is for the correct products.
How did you not solve it? How did you not solve it?
You have to remember that table that about the solubilities of the salt. All nitrates are soluble, most chlorides are soluble except silver, mercury, lead. Okay. Q and R are the elements in the same period of a periodic table. Q has 7 outer electrons, 7 electrons in the outer shell, and R has 2 electrons in the outer shell. So if it is having 2 electrons in the outer shell, which group it belongs to?
Nothing.
So R belongs to group 2. Yeah. And Q belongs to which group? 7. Because they already mentioned it has 7 electrons in the outermost shell. So if 2 electrons in the outermost shell, what likely it will be? It will be a metal. Because metal have group 1, 2, 3 are the metals as well as the transition. And this is group 7. So group 7 will be a non-metal. Non-metal. No, metal or a non-metal, it will be non-metal. Non-metal mostly are gases, but we have bromine is a liquid. Which statement about Q and R is correct? Q is a metal, R is a non-metal. Is it correct? No, it's not correct. Q and R have different number of electron shells. They mention what? They mention they are in the same period. So if two elements belongs to the same period, they will have the same number of shells. Because the number of the shells is given by the period. So if they have same belongs to same period, so they should have the same shells. R is found on the right of a Q in the periodic table.
No, on the left.
R is on the left. The proton of R is less than proton of Q. That's right, because as we move across in a periodic table, the proton number increases. You can see here in the same period, when we have element in the same period, you can see the proton number is increasing. Lithium is 3, beryllium is 4, boron is 5, carbon is 6, nitrogen 7, oxygen 8, fluorine 9, neon 10. So in the same period, when we move, what will happen? The proton number increases. And R was on this side and Q is on this side. So it gives an idea that R is having less protons than Q, because R is on the left hand side and they are in the same period that they already mentioned. So what is the right answer? The proton number of R is less than proton number of Q. Why not B? Q and R, different number of electron shell. Why this is wrong? Because as they already mentioned, that they're in the same period. So when elements belongs to the same period, they will have same number of shells. Like when we talk about these elements, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, they are in the same period and they belongs to the second period, so they will have the same number of shells. Like lithium will have 2 shells, beryllium also have 2 shells, boron also have 2 shells. So the number of the shells depends on the period. So as they mentioned, they're in the same period, so they should have the same number of electron shells. That's why B cannot be the right answer. Question 3. Which statement about alkali metal is correct? Alkali metals, what are the alkali metals? We have lithium, sodium, potassium. Lithium is more denser. First, what will happen to density as we go down the group? Density. Group 1. Density. Density, what happened to density?
Increase.
It increases.
What happened to reactivity? Recall the properties.
Reactivity decrease.
Group 1, alkali
Decrease.
metals.
Oh,
Yeah.
Increase going down the group.
As we go down
Increases
the
going
group, the
down.
reactivity increases. Density, what happened to density? Density. You have to
Increases
memorize.
going down the table.
So 2 options are there, increase or decrease. That's why I'm asking.
Increases going down the table.
Density, what happened to density?
Decrease.
Word. Think about it and give a
I
reason for
said, I
that.
think I said decreases.
The properties of alkali metals, you have to recall the properties. No.
Density increases.
Yeah, for density for all the group, as we go down the group, it increases, irrespective of the type of the group. So if you have alkali metals or you have halogens, if we talk about the reactivity, say this is group 7 and group 1. You have to learn the periodic trend. So first, when we talk about the reactivity, the red arrow is representing the reactivity. What will happen for alkali metals? As we go down the group, the reactivity increases. But for group 7, what will happen to reactivity? Decreases down the group. What will happen to the density? Density for all the group, irrespective of which it increases down the group. It becomes more dense as we go down the group. So density increases here, density also increases here. What about the melting point? For alkali metals, as we go down the group, what will happen to the melting point? It decreases. The melting point is decreasing. But for group 7 or halogens, what will happen to melting point as we go down the group? The melting point will increase because the state also changes. You don't have to learn a reason for that. You have to learn the periodic trend. Like you have to remember the periodic trend rather than in exam. They will not ask reason why, but they will ask that what is the trend. So these are the trends for alkali metals. Reactivity increase, density increase, but the melting point decreases. So we have this question. The element which are here, lithium, sodium, potassium. Okay. First, lithium is more dense than sodium. Is it right? We know density increases as we go down the group. So density increases as we go down. So sodium should be more denser, but they said lithium is more dense. So it is not correct. Sodium is more reactive than potassium. As we go down the group, what will happen to reactivity? Reactivity increases. So sodium is more reactive than potassium? No, potassium is more reactive than sodium because potassium is below sodium. As we go down, the reactivity increases. So potassium is more reactive. Sodium has a higher melting point than potassium. Yeah, that's correct. Because as we know, the melting point, as we go down the group, it decreases. So lithium will have the highest melting point in the group, then followed by sodium and then potassium. So sodium is having a higher melting point than potassium. That's right. So C will be the right answer for this. The density for all the group, it increases. It is not for group 7 or group 1. For all the groups in the periodic table, whenever you go down the group, it increases. You have to remember these periodic trends. Reactivity, density, melting point. Okay. Which row describe the properties of the transition metal? Transition metal, melting point high? Yes. Density high? Yes.
Shall be.
No, I did not say answer. I'm saying yes or no. Form a colored compound?
Yes.
Yes. So high melting point, high density, and form colored compound. So B will be the right answer. So this was past paper pop quiz 2.